Hello everyone and welcome to this tutorial video where I'll be showing you how to build and optimize a jet engine. Now, in my opinion, the jet engines in Stormworks are the easiest engines to work with because they have the fewest parts and they're very powerful. If tuned right, they can be very powerful and decently efficient. So, we're going to get into it and you'll end up with the ability to make a jet engine so you could put it into your helicopter, plane, or any other vehicle. Here on the test platform we have two jet engines. This one here is kind of the blunt force one and this one is the optimized one, which I'll show you. So we're going to go into the steps, show you how to build it all. Of course, the first thing you could do is type in jet. Now there's a whole subcategory here for jet engines, so you can see the various parts that come with the jet engine modular engines. We're going to go through the parts and I'm going to color code them and explain what everything does. So the first one here is the combustion chamber. So the combustion chamber burns the jet fuel to sustain the jet engine. You can see here it has a power, a throttle input, and fuel connection. So we're going to put that over here. I'll make this red, but the point is this one you could see here has a port end right there for fuel. So you obviously need a fuel tank attached to that. And if you go into this, you'll see that it has the throttle. So this is where you apply the throttle and it obviously consumes more or less fuel based on that. It does not have an electric node. So that is the first part. The second one is the compressor. Now I'll make that one yellow. The compressor is what compresses air within the jet engine, and you have to have electricity here. So you can see that it has power, it has the compressor on-off input, and electricity. So I'm going to put that here. Now if I spin this around, you can see there are no ports on this. So we're going to put that right there. But what it does have is a electric node, and it has a compressor on off. So this one has throttle, this one has the compressor. Next we're going to move on, and I'm going to skip the ducts for now. Let's go right into these other ones here, the exhausts. So I'm going to put that here. There's three of them, and the difference is quite important. So the first one is your run-of-the-mill exhaust. It has a air pressure output, temperature output, and thrust spoiler. So you can actually apply a reduction factor in thrust, in essence, to make it not push you forward or push you forward. Now this one here is the same thing. This is called the afterburner, but you see here it says it can burn additional fuel for increased output. So the idea is here that you enable the afterburner, and through this port right there you actually suck in additional fuel. So it's going to be worse for your fuel economy, but you're going to gain more power. And of course it also has the thrust spoiler, so that is to change the forward motion of that. Then we have a rotating one, which is the same as the exhaust regular, but you can apply a pivot to have it move around. So this is good for probably a vertical takeoff aircraft. You could have it vertically take off and then shoot forward. You can adjust the rotation target here. Now the thrust spoiler, like I said, same thing. So these are the three different ones. Only this one has a fuel port, the rest don't. This one is electric powered to move the pivot, the rest aren't. Now keep in mind, I found that you don't need these guys to make your jet engine work. So you can have it work without having the exhaust. And that's important if you have it kind of somewhere inside your ship. So where I tend to really like these or use these is on aircraft, because it gives you the forward motion, and it pretty much gives you a lot of thrust. Obviously not good on helicopters where you need to have a rotor spinning because, well, still good, but a little different. You'd have to accommodate that, and you can give yourself forward momentum. We're not going to go into that, but really for aircraft. Then we can go into the next thing, which is the turbines. Now there are two turbines. We have a medium turbine and we have a small turbine. I'm going to put them here. Now, what is the difference? Well, in size. And what else? Well, the medium one, if we spin it around, you're going to see has a port. That port is for RPS. This one, if you spin it around, does not have any ports. So what's the purpose of this one? Well, if you pair this with one of these, that's how you make like a jet airplane, because now you don't need to have auxiliary power going outwards, where this is one you'll want for a generator, this is one you'll want for a helicopter, pretty much anything where you're taking power out of it into another system that's not one of these. They are the same power, obviously a little bit different weight, but yeah, this one has the additional torque for using. And of course you can pair this up with a generator to kind of jump start it if you don't want to have well, if you want to also make it start up a little faster. Now, what I found from some tests is that, say you don't use this one, say you use this one and this, it actually will start to produce electricity. So you don't really run the risk of running out of electric power if you don't have something like this with a generator attached. Otherwise, you'd have to always use this one because you'd be constrained by your electricity running out. But I found that they do charge things up slowly, so you still may need some auxiliary power. I'm not going to go too much into that, but keep that in mind when you're building your aircraft or helicopter or vehicles. Then we have these intakes. Now the intakes, there's a big one and there's a small one. Pretty different in sizes, you'll see here. Now the nice thing with the small one, it fits right on the front of these. And remember how it's called a modular system? You see kind of like an octagonal shaped shape right there. And that one is where you mount this to the front of these turbines. Okay, but obviously this one is much larger. So why is it larger? Well, interesting enough, it still says the same power, but this one says this intake has turbofans that'll provide additional thrust. So I think you safe to assume you get more power coming out of this one. This is one that I'd imagine you put on like a 747 or something, like a very big airplane. It is pretty big, but this is what I've been using always. And the last thing we're going to look at now are the ducts. Now remember how I just mentioned that you have the ducts? Well, consider them like your pipes, the angled pipe, the straight pipe, that type of thing. So this is your angled pipe, just like that. Then you have a cross, so you kind of have a variety of different things. Now this one's very useful. It can offset it by one block. You have a straight piece if you just need to kind of space it out a little bit. You have a T-piece. So these ones you can use to form the shape of your jet engine, but you don't need them. These are only ducting, whereas these you need. Actually, on that note, I was able to make a jet engine work without an air intake, but the pressure gets really wonky and high, and I don't know how it would sustain power. So I've always used one of these, but it is possible to get it up and running without using one of these. Now these ones you don't need. So I was saying the exhaust, you don't actually need an exhaust. You can have a fully working system like on my helicopter with no exhaust. These things are what you need. Now you need to select one of the blue ones, and you need to take the red and the yellow. We'll start by taking one of these. I want the one that has the RPS. Then we will grab one of these. Now take a look at this. So you have to match the arrows. You can't do this. You can see that interface does not line up. Whereas if I do this, the arrows line up and the square box lines up. So that does help you. And then likewise, this guides us for the propellers. So you could see here, that goes there, and then these ones go there. So you can't really do anything other than what you're seeing here. Of course, this is missing the combustion chamber. So as long as the arrows are lined up, as we've done right here. That is your very, very basic jet engine. Now keep in mind, this guy here is the jet turbine, whereas this guy here is the compressor. So what we're following here with the arrow is the direction of air. So what do we put on the very front? Well, here we put this. So that is the air enters here, flows through the compressor, flows through the combustion chamber, and out the turbine. So if we wanted to, we'd put our afterburner or exhaust right there. So that is, again, the most basic jet engine system. I've experimented with removing certain parts, but not had luck. This is kind of what it comes down to for me. If you have other ideas, let me know in the comments, but I'm just kind of teaching a very basic standard way of doing this. Then what we'll need for sure is a gas tank. Keep in mind, it is quite thirsty, so we've aligned the gas tank here with the combustion chamber. Those two are together. Now, I always recommend and say you have to also put a vent port, otherwise it won't work right. But anyways, that is now on the combustion chamber. Here, where we have RPS, we can go ahead and put a simple propeller. We'll put one that doesn't affect the creation and it's not going to take off on us. And we'll need a battery. So we'll put the battery right here. Now, we got to plug everything in, connect that, and then we have a few nodes to input things. So what I'm going to use is a couple throttles. So we'll line this one up here with this, line this one up here with this, and we'll need a toggle. Now, again, this is a very basic rudimentary system. This is not how I recommend you to do it, other than just to learn the proof of concept. So that's what this is here. So we've connected this to the spoiler. Now that one I'm going to go ahead and set to a 1 start value. You could see that it has 1 is a total reduction. If I don't put 1, this whole thing will fly off into the wall. So I do need to reduce that thrust. This one is for the compressor, and this one here is for the throttle. Now I just need to make sure the rest of these things are connected to the power. And the last thing you got to do is make sure this tank is jet fuel, otherwise it will not work. So what we can do is press this, it turns on our compressor. You could hear it kind of whining, and if you turn the throttle up to 1, now it's going. So at this point you could turn off the compressor, you don't need it anymore, and your system is working. So see how much smoke that exhaust makes? That's why I tend not to have it. Also, check this out. So if you turn that lever, that thing is going to fly off. So for my purposes and for the purposes of this tutorial, we're going to remove this, but you see how it works. So you apply thrust and it gives you forward motion. But if you are making a helicopter or generator or whatever, then you don't need that part. So we're back to this. So again, this turns on the compressor, this gives it throttle, and it will hit, you'll hear it. And at that point you could turn off this, and now the RPS are going to build. Now this engine allows a crazy high RPS. You can actually end up with like 100 or something RPS. It's going to burn fuel like crazy if you're doing that. So you'll definitely want to limit the RPS to around 15, I would say, which is what I'm going to show you in the microcontroller. We'll start off with our empty microcontroller. I recommend you have one of those. And what we're going to do in here is do 6 nodes. So once you have 6 of them, you can adjust them in place and adjust the size of the microcontroller. Now I'm just going to call this Jet MC, and we'll have to define them. So what we'll need is a number input, which is from the collective of the gyro or a throttle. So either or, and that will be coming in. Then we'll need another number input of RPS, and we'll need lastly an on-off input of literally on-off, so on button. Then we'll need an on-off output for the compressor, and then we'll need 2 numbers. First one is a number output for the starter motor, and then the second one is the actual throttle to the jet. So once we have these guys defined, we can hop into the logic and start by arranging them. As I always say is best, just organize yourself such that it's easy to work. Now, first thing we will want to do is put the throttle up at the very top and start off by putting a threshold. Now, the purpose for this threshold is to activate it if it's 1 or more. So you could put 1 and then you could put 999 or whatever. We're just going to put 100. So if your throttle is, or collective is between 1 and 100, go to this value, and then below it we'll need a not. So if it's not that value, then something else happens. Well, what happens? A counter. Now, the nice thing with counters is we'll set this value to up, this value to down, and it will clamp whatever it is we have. Now, I'm going to put 0.001. Reset value doesn't matter. We do want clamp on, and we want it to set to, let's say, 15 and 18. So that means our RPS is going to be 15. Now, you got to test it out for your own helicopter, what works best for you. Sometimes you could get away with a little less. This is kind of a sweet spot I found for a couple of mine. And then we'll need a PID. Now, because this is a beginner tutorial, if you don't know how to use a PID, just follow along. You're going to take this value, put it into your set point. Now, the very first one, the proportional gain, we're going to put to 0.6. The rest, we're just going to leave 0 and 0. And now our RPS is what's going to feed into the process variable. So that's going to now use the set point to try to make the process variable match whatever it is we're setting here, which is between 15 and 18. Now, what's turning this thing on is the on-off button. And then lastly, what we're going to do is put a clamp on coming out of this PID with a minimum value, let's say 0.15, and a maximum of 1. That's going to go to the throttle of the jet. So we want a minimum of 1.5 so the thing doesn't stall out. Now, the next thing we'll do is, remember how we said we needed to have the compressor on while the RPSs are kind of low? Well, let's use another threshold gate. So we're going to use the RPS on a threshold gate, and we'll set the low to 0, and we'll set the high to maybe, let's go 12. We got to go a little less than our minimum RPS here, 15. It doesn't make sense to put this to be 15, because then you're just going to end up always having the compressor on. Now, if you plugged it in here, that won't work, because you're always going to have it on. It's 0. So what you'll want to do is put an and on. There you go. So now if it's on and it's low, then turn the compressor on. And now we have the starter motor, so we're going to use the numerical switch box right here to turn on the starter motor. So if the compressor is on, the starter motor is also on, and it's going to have a constant number of 1 inside this switched value. So that's pretty much it. A pretty basic microcontroller. We're going to throw it in right here. Now, I do need to reconfigure what's coming into this RPS. So we're going to start off with a pipe. I recommend, of course, a generator for whatever it is you're going to be doing. It's useful to have electricity. And then a motor. The motor is going to help turn it on. And then for visual sake, let's just put a propeller. Okay. Now, make sure everything's plugged into the battery first, and then start plugging things in. So we have our starter motor going to the starter motor. We have the RPS going to the RPS. On-off goes to the on-off button. Throttle to jet will go to the throttle to jet. Collective will go to the throttle, and compressor goes to the compressor. So that would work, and that should work. What I like to do is actually put a clutch between this, just so you don't end up spinning it right away. Imagine if it's a boat or whatever, you're going to have instant power. So what I always find useful is to put a clutch. And what you can do yourself is determine if you want to have it on a switch box, meaning you press a button and it goes on or off, or whether you want to have it on a throttle. Now, you can have it on a throttle just like this. And of course, we've got to give electricity to everything. So now if we hit this button, it should fire up. Okay, that didn't work. Why didn't it work? Because this throttle or this RPS could be negative, could be a bunch of stuff. So we do want to put a naught here, plug that there, and rather than having 0 to 12, we're going to have, if it's not, 12 to 999, whatever. So now, if the RPS is not pretty much above 12, then it's going to kick on. So let's try that. We'll fire it up. You can hear it starting, and it pretty much turned on right away. We could turn that throttle up, and of course you could turn that throttle lever up. And take a look. It's hovering at that nice 15 mark. It's going a little higher because of our value here. If you turn that down, it's going to drop. So you probably don't want to ride it at 100. But eventually it picks itself up. You see here now it's hanging out at 14. If you keep putting 1 on, it will hit that 18 mark. So you pretty much have just it's either 1 or not. But it's going to be riding at that 14. So this is good for a plane and exceptionally well for a collective coming out of a helicopter. So there you have it. That's how you make a jet engine. There's a couple parts, but once you figure it out, it's not too difficult. And also now you have a simple microcontroller. So keep in mind, if it's a boat, you do this, it's going to stop. You turn it up, it's going to go. If it's a helicopter, you pretty much want a numerical switch box on off, like a rotor brake or whatever. And with this being attached to the gyro, it will actually keep the helicopter powered up and kind of fluctuate the RPS based on what you need. One really quick change, if you are not doing a helicopter, meaning it's not you don't want a collective, you could go ahead and set this directly to the set point. Now if you do that, just have to make sure that in your throttle lever, this is actually now going to be an RPS set, and you'd be setting it between 1 and 18 or whatever. So keep in mind that would actually work as well. So now if you fire the thing up and turn this on too, so look at that, now we're at 4, kind of hitting 5. It's coming close to this value that we have set here, so just over 5. Now if you turn it up to 16, it'll go to that kind of 16. We're at 15. Turn it down, it'll drop down. So this is another way you could make it such that you're not dependent on either like a plus on or off type scenario. Now you're actually changing the RPS or the revolutions based on your throttle settings. So you wouldn't need this throttle lever, you'll just be using this to make your boat or whatever go. So there you have it. Hopefully you learned something. If not, hopefully you're entertained. Until next time, happy Stormworksing everyone. We got a lot of content, creations, videos, all kinds of stuff coming your way. See you next time.